Chapter number 3 deals with what? Force, Newton's law, first law, second law, third law, and the B part of the same deals with friction, circular motion. That means we have to deal with basically the force and one or two types of forces. Once you understand force, all chapters will have some kind of force. For example, chapter number 6 will have gravitational force. Chapter number 7 will have viscous force. So different chapters in +1 and +2 deal with the force and energy. That is whole syllabus of +1 +2 primarily focuses on two aspects. One, force. Two, energy. That is why first 4 chapters are fundamental. Chapter 3, first part, force. What is force? Yes, force is a push or pull. Even when you enter a showroom, so on the two sides of the door it is written a push and pull. So you push something or you pull something. That is what in a layman's language we term this as a force. So force is a push or a pull. Can do what? Yes. Number 1, produces or tries to produce motion. First part, produces or tries to produce motion. Example, an object is at rest, chair. You apply force. There is an object, chair. You apply force and you set it in motion. This effort, this force was sufficient to set it in motion because the mass of the object was less. Opposing force, small friction on the floor was there. But if you try to push a heavy object, a train or a wall, then do you produce motion? No, because force is not sufficient to overcome opposing forces such as friction. So that means you may produce, the force may produce motion. If it doesn't, it tries. For example, when you apply force to a train at rest, a person pushes a train. So the person is trying to produce a motion, but the outcome is not motion. The train still continues to be at rest. That's the first part, produces or tries to produce motion for an object at rest. 2, stops. Or tries to stop. So there is a cricket ball. You try to stop, it stops. You apply force, it stops. But if there is an aeroplane and you try to stop it, then if a fast moving train you try to stop it, then you may try. Third part, that is changes or tries to change a direction of a body. Changes or tries to change what? Direction of motion. Example, if there is an object moving in one direction, you take a rope and apply a force in perpendicular direction. The outcome is, this is how it looks like. The object will set in circular motion with the same speed. That means speed remains same, but only direction changes. That means this force has done what? Reduce the speed? No. Increases the speed? No. But changes the direction. So number of questions will deal with 3 aspects. Something is at rest and you try to move it. Something is in motion, you try to stop it. Something is moving in a particular direction and you try to change direction. You can do it by applying something, a push or pull, that is termed as force. Then, what are its units? Yes, units, Newton, N. Dimensions, or dimensional formula. Mass into acceleration. Acceleration is what? Length by time square. Time with you is 4 minutes. 4 minutes, and try to quote examples also. I have given you the examples, but I have not written on the board. So try to quote examples also. B part. Different outcomes of force. That means the examples same. 3 types we have shared. 3 types of examples. Again we repeat the same. Different outcomes. 3 possibilities. First one was case number 1. Yes. When you push a ball lying on the ground, it starts rolling. Object is at rest, cricket ball. You apply force and it starts rolling. So your effort has resulted in motion. The force exerted thus produced motion in the ball. However, when you push a heavy stone, very big stone, you apply force and this force is unable to move it. So the outcome is not motion, but the effort, the force has tried for what? To produce motion. This is one case. Case number 2, that is an object is in motion and you want to stop it. First part, a ball falling downward can be easily caught by your hand. Cricket ball moving downward and you catch it. So earlier there was some speed, now you catch it. The final speed is 0. So this force has resulted in stopping it. That effort is successful. 1. Second is, there is a big stone rolling, big rock, big stone rolling, and a person tries to stop it, and the stone keeps on moving. The person is unable to stop it and is you can say, crushed by the person, by the stone. That's the second part. Big piece of rock rolling down a hill cannot be stopped even when we try our best to stop it. Third part, when a piece of stone tied to one end of string is whirled in a circle, a constant force has to be. Case number 3, change of direction. A stone, you apply a force perpendicular. When you keep something in motion, circular motion, you need to have a constant force, a tension in your arm and in the string to maintain circular motion. We will term this as a centripetal force, to be discussed in chapter number 3b. So that means the force is used for what purpose? to change direction. Time with you is 3 minutes to write. C part is contact and non-contact type of force. When you say contact, that means touch. You will have to touch the object. For example, a chair. In case you want to move it, then when I apply force, I touch the chair. That is how a contact, physical contact of an object A applying agency. Agency creating force, the hand, and the object to be set in motion. Contact between the two is must. That is, most of the forces we see in daily life, they are contact type. That's the first part. Force is acting only when we touch the block. So, first part, contact type. There is a block at rest. You apply force. You apply force on this object. The two objects, the block and the hand, they are in touch. That means contact की जरूरत पड़ रही है. Word क्या आना चाहिए? Touch. Non-contact. Number of examples are there. Earth and a ball at a certain height, or a moon. नहीं कहना. A ball or moon at certain distance, certain height. This ball is being attracted by earth because of force of gravity, even at certain distance. That is one example. Example number 2. Strong positive charge nuclei. Alpha particle is moving towards the nuclei. Even at this distance, it experiences a force and gets deflected. There is no contact between alpha particle and a nucleus. So, an alpha particle moving towards the nucleus gets deflected because it is under a constant force of repulsion, electric force between two positive charges. A positive charge repels another positive charge, to be discussed in detail in +2, chapter number 1. So, these are the examples of non-contact, where touch is not required. Here, block and hand, you touch the block. Time with you is 3 minutes to write. 3 minutes to write. Question, if you throw an object upwards, point till the ball leaves the hand is contact type. The moment it leaves, even if now the person is not there, the ball is in air, still its speed is decreasing. Why? Gravitational force. Earth is not in contact with the ball, but still there is a force acting. That means what? Initially it was a contact type. Once it is in air, then it becomes non-contact type. 2 minutes to complete. linear momentum. It is defined as product of mass and velocity. School definition. Cricket ball, mass m, velocity v, momentum is defined as product of mass and velocity. Units. Mass is what? Kilogram. Velocity or speed is what? Meter per second. Dimensions or dimensional formula. Mass is m1, length L1 divided by time. What you get is m1 L1 t minus 1. Dimensional formula of momentum is m1 L1 t minus 1. Time with you is 2 minutes. This was a part of question number 3. B part deals with graphs. Three types of graphs. Graph number 1. Yes. Plot. Yes. PV graph. PV graph. When M is constant. Second. This is first one. Second is what? Yes? P M graph. Keep V constant. Third, we'll take up in the next part because of space constraint. Third is what? V M graph when P is a constant. We'll plot it. Notes band kar do please. Step 1. You have to write a relationship between P, V and M. Whenever you have to plot a graph, procedure is what? Write a formula or a relationship. How one depends on other. Formula, yes. P is equal to MV. So you want to plot a graph P as a function of a V. Try. 2 minutes to try. Let's see how many of you. M constant means any value. You can take M is equal to 2. M is constant. So your choice, you can take any value of M. Say M is equal to 2. Comes out to be what? Straight line. How many of you have drawn straight line graph? Procedure is P is along y-axis, write this as y. V is along x-axis, write V as x. M is constant, your choice, any value 2. First of all, you plot graph y x graph. When x is 0, you can make a table. When x is 0, y is what? 0. When x is 1, y is, yes, when x is 1, y is 2, correct. When x is 2, y is 0 to 4. Here PV graph, same, anyone, slope of the graph gives what? Slope of graph, y is equal to 2x. If you differentiate, you find dy by dx is equal to what? 2. If you find dp by dv, I am writing it here, dp by dv, m is what? Constant, is equal to m. Slope gives what? M. In competition, they won't write mass of an object is 2. They will say slope of PV graph for a constant mass is given to be 2. You will have to conclude that slope of PV graph deals with what? Slope of PV graph gives mass. Indirect data. 1. 2. PM graph. P as a function of M. When V is a constant. Formula P is equal to M V. P is equal to V M. This is constant. Try. Procedure. Yx. Question is PM graph when speed of an object is constant. I will explain. When a rocket is moving upward with a constant speed, what is the status of the mass? It ejects gases. Its mass changes. So we will have come across number of cases. Practically, when you fill your car with fuel, petrol, diesel or gas, you move from say one city to another city. Your speed changes. You're not moving at a constant speed. Speed changes. And petrol fuel is also being lost. So mass changes. So what is the practical? Both mass and speed change. For a cricket ball, you can assume the mass of the object remains constant, but its speed changes. So you have different cases. So at present, we don't have a discussion for examples because we will come across these in various chapters in +1 and +2. P is equal to Vm. Yes, P is what? Y. M is what? X. V is what? Constant, say 2. Then again, same graph. Now slope gives what? Gives velocity or magnitude of that is speed. This was first case. This is second graph. Third graph. Yes. Third graph deals with what? Graph number 3. Yes. Graph number 3 deals with, I will write V as a function of M. When P is constant. Formula, first step, P is equal to mv. V is equal to P by m. When you have to plot this graph, V as a function of m, you will write V as what? Y. V is along y-axis. M is along x-axis. And P is what? Constant. For convenience, let me write 10. Plot y-x graph. You can make a table. I will suggest certain values. 1, 2, 5, 10. Try. When x is 1, y is what? When x is 1, y is 2. If it is 5, 10 by 5, 2. If x is equal to 10, 10 by 10, 1. So, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. When x is 1, y is 10. When x is 2, y is 5. When x is 5, y is 2. When x is 10, y is 1. Join all these points. As m increases, yes, velocity decreases if you keep p to be constant. You can refer to the notes now. Slope changes. Slope is not constant, that is why we won't discuss what does it mean here. Refer to next question, question number 4. Question number 4 is Newton's laws of motion. Yes. First, second, and third law. Yes, anyone from this side? First law, school work. Yes. When object is at rest, it will continue to be in state of rest. First law. If object is at rest, will continue to be at rest. If object is in motion, it will continue to be in motion until unless acted upon by external agency, that is force. This is known as Newton's first law. According to this law, a body continues to state of rest or of uniform motion along a straight line unless it is acted upon by some external force to change its state of rest or motion. Second law. The statement is force is proportional to rate of change of momentum. Force is proportional to rate of change of momentum with respect to time, that is dp by dt. If you want to bring in large change in momentum in a less time, change in momentum dp is large, time taken is less, then this force is very large. Large force is required to cause more change in momentum in less time. Like a cricket bat hitting the ball, the time is very small, but change in momentum is large. So large force is required. According to this law, the rate of change of linear momentum of a body is directly proportional to external force applied on the body, and this change takes place in the direction of force applied. Means what? F is equal to dp by dt, means it will take into account the directional aspect also. Third law. Yes. Action and reaction are equal and opposite. Action and reaction are equal and opposite. Time with you is 3 minutes. School work, 9th class, 3-mark question. Question number 5. Deals with what? Newton's first law. That means state, explain, give examples for Newton's first law. Again, the law is same, no change. Statement. If the net external force on the body is 0, that means if there is no force acting, its acceleration is 0. Acceleration 0 means what? Velocity is constant. Constant velocity has two meanings. If v is constant, v constant means what? It can be 0, it can be non-zero, that is 10. So if it is 0, object is at rest. If it is 10, it is moving with what speed? 10 meter per second, and will continue to move with the same speed. Simple statement, school level is an object at rest will continue to be at rest, in motion it will continue to be in motion until unless acted upon by some external agency. In a complex format at +1 level, we can say as per the formula, this is to be, you can say, proved in second law. F is equal to ma, right? To be proved in second law. As per this, if force is 0, that will mean what? A is 0. If there is no external agency acting, acceleration is 0. When you say acceleration is 0, that means what? dv by dt is 0. Differentiation of something is 0 means that physical quantity is constant. When you say velocity is constant, it has two meanings. Either it is 0 or it is 10 meter per second. So, in simple form, it is object at rest will continue to be at rest, in motion continue to be in motion. If you say that prove it from second law, then we explain first law using second law. So in competition also you have a question. Out of three, which one is fundamental law? Second law is a fundamental law because first and third can be explained using second law. So now this is second law, F is equal to ma. We will come out with the same conclusion from second law. And it is what? Then explanation, rest. First listen to the explanation. Rest, motion and direction. First part, a body at rest will continue to be at rest. So in this one, three parts for discussion. First is rest. Object at rest will continue to be at rest until unless you apply a force. Second, motion. If there is an object in motion, it will continue to be in motion until unless you apply some force, external force to stop it. Third is direction. If a body is moving in a straight line, you can change its direction. By some external agency. Apply force, say perpendicular direction, and the object starts moving in a circular motion. So if an object is moving in a particular direction, it cannot change its direction at its own. Had it been the case, motion of vehicle on road was not possible because vehicle can change its direction at its own. Now, object cannot change its direction of motion at its own. What do you do to change the direction? You have a steering. Fine, you use steering, you get reaction from the flow, and that is why the tires turn in a particular direction and you can change the direction. So, the first law takes into account something when the object is at rest, next part when it is in motion, third is when it is moving in a particular direction. Even if you need to change a direction, then you need a force. Time with you is 4 minutes to write. 4 minutes to write.